You're staring blankly at your computer screen. It's early in the morning. You just typed the word continue again. This is the fifth time you typed it today. The AI stopped at the exact same spot. It sits there waiting for your explicit permission. Beat. It completely shatters your deep state of focus.
It really is an incredibly frustrating loop. We are, constantly moving away from manual prompting, but that habit is hard to break.
Right. So let's unpack this together right now. Welcome to our deep dive for today. We're exploring a fascinating new workflow concept. It's called loop engineering for autonomous AI work.
This represents a massive shift in human-computer interaction. It completely changes how we build modern software. It really is a game changer for developers.
Today, we'll unpack the underlying mechanics of AI loops. We'll explore 5 real-world agentic loops you can copy. We'll also discuss the harsh realities involved here. Specifically, we'll look at spiraling API token costs. API token costs are the digital currency you pay for AI processing.
It's a profoundly important topic for modern developers. It basically changes how we think about autonomous digital labor. You're essentially managing a tiny digital worker.
I think a lot about how we interact with machines. Beat, we basically treat standard AI like a timid intern. This intern might be incredibly brilliant at complex tasks, but they need your approval for every single keystroke.
Yeah, that's a perfect way to frame the relationship. We're constantly babysitting the artificial intelligence all day long. We have to hold its hand through every single step.
But an AI loop fundamentally changes that entire dynamic. It's much more like a robotic Roomba. You just let the Roomba map the entire floor first. It stops automatically when the room is fully clean.
What's fascinating here is the core underlying issue. The primary problem isn't the AI's actual coding capability. The AI handles the complex coding work incredibly easily. The real problem is it just doesn't know when to stop.
I still wrestle with prompt drift myself. You try giving the AI too many sequential instructions, it eventually just loses the main plot completely. The context window gets too crowded with complex logic.
And a context window is the short-term memory an AI uses.
Right. It just forgets what it was originally doing.
That's exactly why these AI loops are so incredibly powerful. An AI loop simplifies the entire process significantly. It basically requires 2 fundamental things to run properly.
First, you need a very specific, clearly defined goal. The system absolutely needs to know when the job is actually done.
Right, and the second is explicit permission. It needs permission to check, fix, and retry automatically. You don't type anything between the steps at all. The loop handles the entire iterative cycle on its own.
It isn't just some magic one-click button, though. It's a specific prompt paired with a strict stop condition. You have to design those boundaries very carefully beforehand.
Yeah, this stop condition is the most critical piece. There are 3 main triggers that usually start these loops. Manual triggers are simply started directly by you in the terminal.
Scheduled triggers run automatically at specific preset times. They might run every single night at midnight while you sleep.
Exactly. And action-based triggers run after a specific software event occurs, like someone opening a pull request in your repository system. A pull request is a formal proposal to merge new code changes.
The goals themselves generally fall into 2 distinct categories. Verifiable goals are measured by hard mathematical numbers. LLM as judge goals mean the AI subjectively decides if it's good enough.
We'll explore both of those distinct categories today. Matthew Berman actually created something called the Loop Library. He runs an AI loop on his production errors daily.
It autonomously reads the server logs for anything actionable. It fixes the error and rigorously verifies the code fix. Then it opens a pull request right there in the system.
And if it finds absolutely nothing wrong, it just stops.
Yeah.
It doesn't invent random tasks just to look busy.
If the AI runs completely on its own, how do we trust it doesn't just invent fake work to look busy?
Well, clear boundaries and strict stop conditions prevent that exact scenario. If it sees no actionable errors, the prompt tells it to halt immediately. There is no ambiguity.
So with strict boundaries, it simply stops when there's nothing to fix.
Yes. It doesn't hallucinate fake problems just to seem productive. It simply stops working and waits patiently for tomorrow.
Let's move into the verifiable loops right now. These rely heavily on pure speed and system stability. They use hard numbers and explicit machine-readable server logs. We're talking about highly objective, measurable success metrics here.
Verifiable goals are always much easier to trust entirely. The fuzzier the goal, the harder it is to trust the AI. Hard numbers leave absolutely no room for subjective interpretation.
The first one is the sub-50 millisecond page load loop. The ultimate goal here is one single crystal clear number.
Every single web page must load in under 50 milliseconds. That's blazing fast for any modern web application today.
The AI continuously measures how long each page takes. It hunts for whatever is slowing the specific code down. It looks for heavy, unoptimized images or slow database queries. It also looks for extra JavaScript that delays the page loading.
Yeah, it identifies the bottleneck and writes a targeted fix autonomously. Then it immediately remeasures the speed to verify the improvement. It keeps repeating this cycle until every page hits the strict target.
The author of our source ran this exact loop himself. He used a powerful tool called Claude Code for this experiment. Claude came up with 3 specific optimization steps entirely on its own.
First, it created a strict baseline for the original code file. The file was over 112,000 bytes in total size. The initial load time was sitting at roughly 0.7 milliseconds.
Then the AI took its very first optimization action. It actually dropped the Google Fonts content delivery network entirely. It switched the code to use local system fonts instead.
Which is incredibly smart. Local fonts eliminate the need for extra network requests.
Then it went ahead and minified the CSS code files. Minified CSS means removing empty spaces to make code files smaller. It squeezed the file down to its absolute smallest possible footprint.
Right. The final file size dropped to roughly 108,000 bytes overall. The load time successfully hit 0.6 milliseconds on the server. Every single page comfortably came in under the 50 millisecond mark.
It actually achieved the explicit goal perfectly without human intervention. Matthew Berman ran his version of this loop for nearly 50 minutes. It just quietly chipped away at the Codebase performance constantly.
This specific loop is best for existing, stable web pages. It's definitely not meant for sites currently under heavy construction.
If the site is changing constantly, the performance benchmark keeps moving. The AI will end up chasing a constantly moving target indefinitely. You have to give it a completely stable foundation to optimize.
Exactly. The second verifiable loop is the production error sweep. It reviews your live production logs for any actionable software errors.
It traces those exact errors down to their underlying root causes. It writes the necessary fix and thoroughly verifies the code changes. Finally, it opens a pull request for a human developer to review.
It repeats this exact cycle until the server logs are completely clean.
I have to be brutally honest with you right now. Letting AI automatically fix live production code feels incredibly wild. It's honestly like letting a ghost drive your car. 2-sec silence. You're handing over the steering wheel to an invisible entity.
It definitely requires a massive leap of faith at first. But remember those strict algorithmic boundaries we discussed earlier today. It only acts on explicit documented errors found in the logs. It isn't just rewriting your entire system architecture for fun.
What happens to the error sweep loop if a company's logging is just thin or vague?
The loop will completely fall apart almost immediately. Thin logging gives the AI absolutely nothing concrete to actually investigate. That's exactly why doing a logging coverage pass beforehand is absolutely crucial. You have to give the AI a clear map to follow.
Right. Poor logs mean the AI has absolutely nothing to actually investigate.
Exactly. It needs rich, detailed data to find the true root cause. Without highly descriptive logs, it's flying completely blind in the dark.
Here's where it gets incredibly interesting for us today. We're leaving the safe comfort of hard, verifiable numerical metrics. We're entering much fuzzier, inherently subjective territory right now.
This is the LLM as judge category of autonomous AI loops. The AI evaluates its own work without using strict, hard metrics. It relies entirely on its own semantic understanding of the given task.
The third loop is widely known as the doc sweep. You basically give the AI a recurring nightly maintenance job. It must keep documentation in perfect sync with Codebase changes.
It meticulously reviews the entire Codebase every single night. It compares the raw code against the current written documentation.
It systematically finds any sections that have gone completely stale. It thoughtfully updates those sections and verifies the text changes itself. Then it opens a pull request for a human review tomorrow.
With a standing no-push instruction, it commits the files locally instead. A no-push instruction stops it from publishing code live automatically. It keeps the changes safely isolated on your own local machine.
The author ran this specific loop on his own machine recently. Claude actually flagged a completely unrelated PDF document almost immediately.
It instantly recognized the PDF wasn't relevant and set it aside. It didn't waste expensive compute time trying to parse a random manual.
Then it wrote a brand new re-ADME file from scratch. It carefully covered the project layout and the entire server setup. It even documented those 50-millisecond font optimizations we discussed earlier.
Then it reran the Codebase benchmark to confirm nothing broke. It committed the final changes locally exactly as it was instructed.
This specific loop fits teams that ship new code very frequently. Documentation quietly falls behind when you move at extremely high speeds. Developers almost never want to stop and update the text files.
Yeah, but if your codebase barely changes, this loop basically does nothing. It just checks the files and gracefully goes right back to sleep.
The fourth loop is a massive SEO visibility loop. SEO stands for Search Engine Optimization for Modern Websites. This is how you ensure people can actually find your web content.
This loop autonomously audits crawlability, indexation, page titles, and internal links. It basically checks how easily search engines can read your entire site.
It closely examines structured data and answer-first content formatting. It's like stacking Lego blocks of data. Beat. The AI methodically snaps unstructured information into a rigid structure. It builds something that search engines can easily read and understand.
It systematically ranks all the identified gaps by their expected impact. It fixes the absolute highest leverage issue it can possibly find first.
Then it reruns comprehensive audits across major search engines and AI answer engines. It keeps going until no critical technical issues remain unresolved. Beat. Whoa. Beat.
Imagine scaling to 1 billion queries.
It's a staggering amount of unstructured data to process. This loop actually covers 8 separate technical ranking factors continuously. It's an incredibly complex web of interconnected metrics to balance correctly.
Because of that complexity, it sits heavily in the token usage category. You should generally run this one weekly, not as a daily task. Search engine crawl results and AI citations shift very slowly anyway. Running it every single day would largely be a waste of resources.
Isn't it inherently risky to let the AI be the judge of its own SEO fixes?
Well, it is incredibly risky in this specific, highly subjective context. That's exactly why the verify step requires such intense preparation beforehand. You must strictly record exact target queries before it even starts. You need absolute benchmark methods securely locked in place first.
You have to lock down the baseline metrics before letting it judge.
Yes. Without a rigid, predefined baseline, it might optimize for the wrong things entirely. You absolutely have to measure against that exact same set after every fix. Mid-roll sponsor read.
We're pushing LLM as judge to its absolute functional limit now. We're closely examining the full product evaluation loop. This is the 5th and final loop we are covering today.
This is easily the most open-ended loop of them all. It requires the AI to understand complex user intent and product functionality.
Before it even touches the live site, it prepares meticulously. It spins up a local replica of your live production environment. It designs highly realistic test scenarios covering every major software feature.
It explicitly defines strict pass and fail criteria for each scenario. It runs all those complex scenarios under the exact same conditions. It essentially simulates thousands of users interacting with your application simultaneously.
It carefully records the evidence, logs any failures, and fixes root causes. Then it systematically reruns the affected scenarios over and over again.
It basically repeats this intense cycle until every scenario holds against the bar. Matthew Berman actually used a variant of this on his own product. He had the AI generate 100 different, highly complex test questions.
These were specific test questions for a feature involving AI responses. Each response got judged heavily for factual accuracy and proper sourcing. Whatever fell short of the strict standard got fixed by the loop immediately.
There's absolutely no single metric deciding pass or fail here. The AI has to subjectively judge quality against your preset bar. It requires a very advanced reasoning model to work correctly.
Which brings us to the very dangerous traps involved here. You must absolutely not use loops for brand new software features. Do not use them for things built completely from scratch today.
Right. A task with nothing yet to measure will predictably fail completely. Building a brand new feature from scratch is the clearest example possible. The AI needs a solid foundation to iterate upon successfully.
Building a brand new feature from scratch with an AI loop seems like trying to build a house blindfolded. 2-sec silence. You have absolutely no idea if the walls are even straight.
That's a very accurate and genuinely terrifying visual analogy. A loop can run in the totally wrong direction for hours. Without existing benchmarks, it genuinely never knows it is off track. It will confidently build a completely broken system for you.
Loops definitely work best on something that already exists today. They work beautifully on things that just need minor iterative improvements.
And that naturally leads us to a very harsh financial reality. The computational costs associated with these loops add up incredibly fast. You're paying for every single piece of text the AI processes.
The loop runs through many complex, data-heavy steps in a row. The author ran several of these loops himself just recently. He quickly hit his daily limits on Claude Code Pro and Codex Pro tiers.
His API usage climbed drastically faster than he originally expected. The AI consumes context continuously as it iterates through the entire codebase.
If it's just running quietly in the background, how fast can these API costs actually spiral?
Terrifyingly fast. Because it works continuously without pausing, you can hit a daily usage limit in just a few dozen minutes. It processes thousands of tokens every single second it runs.
Wow, so you can burn a daily token limit in just minutes.
Exactly. A loop that runs long eats through massive token usage quickly. It keeps working the entire time without taking any human breaks. It rereads the entire context history during every single iterative step. You absolutely must watch the cost closely those first few times.
Okay, let's pull all of this complex information together now. AI loops transform simple, single-task chatbots into agentic workflow powerhouses. We're moving from simple text generation to autonomous digital labor.
The fundamental secret isn't some hidden, highly complex coding magic. It is simply a clear goal paired with explicit permission to loop. You give the machine clear boundaries and get out of the way.
You should always start your experiments with verifiable hard numbers first. Things like simple page load times are a perfectly safe starting place. You can clearly measure if the AI is succeeding or failing instantly.
Master those objective metrics before moving to open-ended subjective scenarios.
Yeah.
The LLM as judge loops require a much deeper understanding of prompt engineering, and you must always watch those API token costs incredibly closely.
This raises a massive, almost existential philosophical question for our future. If an AI can now autonomously identify hidden production errors, right, and if it can write the fix, verify it, and push the code, beat. At what point does a software developer transition from being a coder to simply being a manager of AI agents? Beat. And what does that practically mean for junior developers trying to learn the ropes?
It fundamentally changes the entire modern career trajectory for software engineers. Developers might become high-level system architects much earlier in their careers. They'll spend less time typing and more time orchestrating complex systems. The true skill shifts from writing syntax to designing flawless verification loops.
It really does challenge everything we currently know about coding. I highly encourage you to try implementing just one loop today. Try setting up a simple, highly verifiable loop this week for yourself. See how it radically changes your own daily development workflow.
It might just save you a massive amount of tedious manual typing. It frees your mind to focus on the much bigger architectural picture.
You'll never have to babysit the timid intern ever again. You can just let the robotic Roomba clean the entire floor autonomously. Thank you for joining this deep dive with us today. Audi Horo Music.